Let's take a little closer look at asymptotes. Now recall, we talked about these in an earlier section. So first, let's define what we mean by horizontal and vertical asymptote. So first of all, horizontal asymptote. The graph of a function f at x will have a horizontal asymptote, a horizontal line that the function will get very close to. But it'll have a horizontal asymptote of y equals a. Remember, horizontal asymptotes are always y equals something. If f at x approaches a as x approaches either infinity or negative infinity or both. So we have a horizontal asymptote if the function gets very, 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 very close to a as x goes way off to the right or x goes way off to the left, or maybe both. Now, one of the things that we need to be careful about that you may have heard that's not a true statement is a horizontal asymptote is not a line that the function gets very close to and doesn't touch. We actually could have a function that crosses once or many times its horizontal asymptote. So by definition, really, a horizontal asymptote is a horizontal line that the function will get very close to as x gets large or x gets small. But it may, someplace along the way, cross that horizontal asymptote one or more times. That's not going to be true about a vertical asymptote of a function. So a graph of f at x is going to have a vertical asymptote whose equation would be x equals a. So this is x equals. If the function either goes to infinity or negative infinity as x approaches a. So what happens with a vertical asymptote is the function either shoots up to infinity or seems to shoot down to negative infinity. And so using our limit notation, we will actually have a vertical asymptote if the limit as x approaches a of the function is either plus or minus infinity. We actually saw earlier on that y equals a times b to the t has a horizontal asymptote. And what we will learn here is that log x has a vertical asymptote.